Hello everyone, welcome back to the new video. So today we'll be talking about this very interesting paper that's titled as Want to Reduce Labeling Cost? GPT-3 Can Help. This is from researchers from Microsoft, and this paper came out this year in month of August. So at very high level, the paper essentially talks about using the GPT-3 language model to automate the process of data annotation. So data annotation is again one of the early tasks that you perform while working on supervised problems, which is usually seen and is one of the time-consuming process in the entire model development cycle. Although you have many options, such as if you're working with large-scale data, then you can work with Amazon's mechanical turk, whereas it might be fine for you to hire smaller group for smaller projects. But again, at the end of the day, both the cycles are going to be heavy on your pocket. So with this paper, we'll compare the annotation cost of GPT-3 versus humans. And we'll also try to answer whether it's okay in terms of performance to train downstream models based on just GPT-3 labels. So as the abstract says, there have been previous work that have talked about generating these pseudo labels, but they require you to have a decent amount of hand labeled data to even start with. And now in this paper, since we talk about GPT-3 model, which means the model already is a pretty large language model and has been shown to have good zero-shot capabilities. So in this paper, we'll try to figure out if GPT-3 can help us doing this annotation task with very less amount of human labeled data. Hence, we'll kind of do a trade-off between the performance and the number of examples that we annotate to have a decent downstream model performance. So the authors test the performance of the labels for NLG and NLU tasks, where for NLG tasks, they I think consider the summarization and related tasks, and for NLU, they have sentiment classification and so on. And they found out that with GPT-3, they were able to save approximately 50 to 96% of the label cost, yet having the similar performance of the downstream model. So yeah, that's pretty cool. Also for this paper, authors tested out Pegasus and Roberta as the choice of their models for NLG and NLU respectively for training the downstream models after you have labeled the data using GPT-3. Also talking about the cost comparison for the task of sentiment analysis, let's say, GPT-3 on average took $0.002 to annotate one sentence, whereas the crowdsourcing platform took roughly $0.11 to label one instance. So that's a huge margin if you see. So clearly we can notice the impact of this paper now. So let's move forward and see the exact method to what they employ. So as I said, since GPT-3 is a language model, which means at every time step t, let's say if this was the sentence that we had, if we were to produce what was at this point, then we would produce a softmax over the entire vocabulary based on all the words that my model has seen in the past. So this is how we train these models, and these are also called autoregressive models. So the way they use GPT-3 models for doing the labeling part is that they append some n number of prompts before the actual sentence for which they want to target a label. So let's say for sentiment classification, which is an NLU task, this was one of the examples and it had a label negative. So this is already you have some ground truth data. So you stack some n instances of these where they play around with I think 1, 2, 3 and 4. Then you have another example which is unlabeled, and then your model is supposed to produce a next word which should be the label ideally, because that's the pattern it has seen in the past as well. So this is how you generate a label data. And now if we talk about any generative task, let's say summarization, you again have a context, you have a summary, you have n such pairs, 1, 2, 4, let's say, any of that number. And then for the newer sample, you just have the context. You pass this entire string to the GPT-3 model and you start generating word by word till the stop signal is reached. So which is again one of the special symbols. Till that, you sample at every time step to output a word. Now there could be multiple strategies to how do you sample. I do have a paper that explains that in detail. I'll try to link that in the I button, make sure to check that out. So yeah, this is the entire strategy to how do you use GPT-3 model. And as you can see over here, right, we are doing a n-shot evaluation of GPT-3 directly. And we're not training it, because now if we talk about training a GPT-3 model, that's clearly going to be a hell lot of pricey. So that's the exact point of this paper, that if we can use the n-shot capability of GPT-3 for doing the auto labeling or not. Okay. So now talking about the labeling cost analysis, the authors only consider the labeling cost charged per label, which is at every sentence level for both the API and the crowdsourcing platform. So this is the table of what they derive. So these are the 6 datasets for NLU and 3 datasets for NLG. These are the number of tokens per example on average. Here 2 short, 4 short and 8 short are nothing but the pre-labeled examples that you need before you make prediction for the new one. which is again that stacked thing that we discussed, which is, let's say you feed 3 examples with their labels, and then you feed the context for the 4th example. GPT is supposed to predict the label for that. So this is the value of n, which goes as 8, 4 and 2. So for humans it takes $0.11 on average for all of these tasks, whereas if you clearly compare Too Short with the humans, the model generated labels are way less costly. So this is close to 6.3 into 10 to the power minus 3, whereas this is 0.011. And as expected, as we go from 2 to 8, the labeling cost also increases, because now you're giving in more context for GPT-3 to process. Okay. So authors essentially test out 4 variations to the labeling process, where first one being using just humans for the labeling process. So you have some unlabeled data and definitely some dollars in a pocket. You hire a couple of humans or you use crowdsourcing platform and you get labels for your training data. So this is the first experiment. Then the second one being using just GPT-3 for the labeling process. Again, considering documents and dollars to be in place, you use the pre-trained GPT-3 model and get the labels for the data. The third one uses the combination of both humans and GPT-3. So let's say your corpus had n documents. You randomly divide them into 2 subsets, let's say n1 and n2. And none of the examples are overlapping between these 2 sets. You use humans for one of the sets. You use the model for another set. And that we get a mixture of labeled data from humans. Let's call this as H1. And then you get labeled data from GPT-3. Let's call it as G1. So talking about the fourth and the final variation, they do GPT-3 plus human active labeling, which means you have a corpus C of certain number of documents, you have dollars, you pass it through the GPT-3 model. GPT-3 will return label for all those examples. Out of all of them, you chunk out the ones that have low confidence, or indirectly it means that the softmax probability is pretty low for that label. You spend some more bucks to label only those examples. So for this case, it would be just 2 examples. You relabel them and append them with the high confidence labels that GPT-3 already had. So this way you get your training data labeled. Okay. So for the first case where we talk about GPT-3 labeling process, this is the formal statement. You have certain number of labeled data, which means let's say you have sentence S and then the label L. In case of NLU task, and for NLG you will have obviously sentence S1 and then sentence S2, which is let's say a summary for sentence 1. And then you have an unlabeled sample. You pass both of them in a concatenated fashion to the GPT-3 model, and it will output a text sequence with their corresponding logics. So let's say for the task of sentiment classification or intent detection, you just label the first word because that is what is considered as a label. Whereas for summary and all of that, you sample till the stop token is reached. Okay. So similarly, it will go for human labeling. Now talking about the third case, which is GPT-3 and human labeling, we saw a bridge-like structure, right? You have document, it goes through humans and some go through GPT-3, and finally you create a dataset by merging both of them. So under this, the idea is given a fixed budget, we split it for labeling by humans and GPT-3. In this way, the in-house model is exposed to the data from both the sources. So now the training loss that you have forms a dual supervision from both the sets. So this is from GPT and this is from humans. Considering T to be the split of that set that goes to GPT and H to be that split that goes to humans. And then you parameterize the loss from humans as alpha, depending on how much weight you want the loss generated from the humans to be considered by the downstream model. So they try out various experiments based on the budget splits, where they try out 0 to 100% of the budget type for creating each of the subsets to be labeled by the respective process. So for example, if I say 75% of my budget I'll be using for GPT-3, then whatever set is being formed will be consuming 75% of the entire budget to be labeled by GPT-3 model, whereas remaining 25% of the budget will be used to create the set to be labeled by humans. So they also call this process as random labeling, because the creation of the set for the unlabeled data that should go to GPT-3 or humans is essentially random, which kind of is a motivation to have more sophisticated technique for which they have active labeling. So as we have earlier seen in the figure, that here we use the logics that you generate for every label or for every word, so to say, which kind of tells the confidence of generation at that point. So they propose active labeling strategy where we have humans in loop that re-annotate the GPT-3 labels that were uncertain. So if we see this empirical evaluation, we can clearly see, right, for the Trek dataset, let's say. So if we play around with top 10% of the words that have really high confidence, the accuracy of the model is also really high. As we go more towards getting a flattened distribution, the model is likely to confuse, so is the accuracy, which can be seen in this figure. So as we increase the top percent, the accuracy is going down. So these are inversely correlated. And same thing can be seen for other two datasets. So now if we talk about the cost comparison for the active and the random labeling, we can clearly see that the active labeling is surpassing random labeling for all three datasets. So at any cost C, let's say this or this one, the accuracy of the downstream model that you get is higher when you do active labeling rather than random labeling. So yeah, I think now we are done with the paper. So as I already said in the starting, like it was a quite interesting read, and clearly this is going to benefit and ease out many of the data annotation processes. So yeah, having said that, if you like my content, make sure to hit that like button and subscribe to the channel. And we are just 4 members away from reaching 3,000 strong. So please recheck if the subscribe button is clicked or not. I'll meet you in the next one with another interesting paper. Till then, take care and bye-bye.